So in this video, I'm going to be going over problem 8 from chapter 11 in the ACS study guide from conjugated systems and aromaticity. So starting with this, we want to go through each of these structures and identify if they're aromatic or not. So you want to go through the two, see if the molecules pass the two steps, which is the first step is that they are planar and cyclic. And then the other criteria is if the MO diagram has fully filled HOMO. Sorry, that should be helpful. Okay, HOMO. So starting off with this first one, we can obviously see that's cyclic because it's in a circle. And then next it's planar because so all of these carbon atoms are all sp2 hybridized, including this one too, because there's just one hydrogen coming off of it. So this one does pass the first test. And then for the second test, I'm just going to draw a little MO diagram down here. So we can see it has 1 and then 2, 3, 4, 5, 6, 7 carbons. So we're going to have to set it up like this, a little line for each carbon. 1, 2, 3, 4, 5, 6, 7. Perfect. Okay. So now we're going to have to fill in each of these, and you really should have an arrow here explaining that this is an energy diagram, but space is kind of small. So you're going to want to add an arrow, add 2 arrows for each double bond because 2 pi electrons. So 1, 2, and then have to add like this. That's the 6. But then up here we have to see that this one can be delocalized into the ring, so we have to add 2 more. This has a half-fooled HOMO, so this is not going to pass the second test. So we know that 1 is not aromatic. So moving on to the second molecule. It does pass the first test because all of these are sp2 hybridized, meaning that it's planar and it is also cyclic. And then for the second criteria, we're going to draw the diagram. Again, I'm sorry, the space is so small. So we're going to have to add 6 electrons for the 3 pi bonds that are there. 1, 2, 3, 4, 5, 6. And then these 2 lone pairs cannot be delocalized, so we do know that this right here is a full HOMO. If you can see, there's 4 electrons in the HOMO, and so it's full HOMO. So this one is going to be aromatic, so we can circle it. Okay, and then for this last one, it is cyclic and it's planar, once again, because these are all sp2 hybridized. And then for the second criteria at the MO diagram, same thing again. We're going to be adding 2 for this pi bond and then 2 for this pi bond, electrons that is. And then we this would look like it's not full because this is only a half HOMO, or half full HOMO. But then we can see that this oxygen has 2 sets of lone pairs, meaning that these can be delocalized into the ring through resonance, so we can add 2 more electrons, because not all 4 of them can, only 2 of them can. So then this creates a full HOMO, meaning that 2 and 3 are both aromatic, so the correct answer is going to be C.